Alrighty, this video is over units and dimensional analysis. You need to be familiar with what units are and be able to convert from the base unit to whatever units you're working with. In dimensional analysis, you'll go between individual units. So here are units of measurement. So here's what you need to fill in. So mass, we're going to use kilogram. In the parentheses is the abbreviation. I'm going to go fast, so pause as needed. Those are all your units: times, seconds, temperatures in kelvins, amounts are in moles. Electric current is going to be in amperes. Luminous intensity is in the candelas. And then you have something called derived units. But we're going to use 3 derived units. That's going to be volume, which can be liters, milliliters, or cubic centimeters. Then you have pressure, which is going to be in pascals. A lot of time you'll see it in cubic. And then you're going to be using energies. It's going to be in joules. This is the main thing you need to be able to know. These abbreviations over here are going to go in front of whatever unit you're working with. And over here, I put whatever unit is going to be an X. So X can equal grams, meters, moles, joules. It's going to be anything like that. So it can be a gigameter would be an M, a megajoule would be MJ, a kilopascal would be KPA. You're going to be using all those things. You need to be able to convert from a kilopascal all the way back to a normal pascal, or from a gigameter all the way back down to a meter. So that's what this is doing for you. So over here you have 1 giga whatever equals 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 of whatever you have. So 1 gigameter equals 1 with 9 nines of meters. And you see the number of zeros correlates with the exponent, so 9 zeros. Over here 6 equals 6 zeros. So you know that mega is 9 zeros, or a giga is 9 zeros, mega is 6 zeros, kilo is 3 zeros, and on and on and on and on. Now once you pass your base unit, which is going to be right here, now it goes backwards. Because now a deci, we'll just stay in meters. Decimeter is going to be, 10 decimeters equals 1 meter. 100 centimeters equals 1 meter. It just keeps on going like that. It just flipped to be into a decimal form instead of in a whole number form up at top. So make sure you guys get that down here. I know you can't really see it. That's 1 million, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros of nano whatevers equals 1, whatever you work on. Why I did that. Well, there it is for you. Okay, so dimensional analysis. You're going to have to pause and go through this a couple of times because there are a lot of steps in doing dimensional analysis. Once you start practicing with dimensional analysis, you don't have to think about the steps. So the first thing is draw the dimensional analysis grid. Most of you guys will see something that looks like a plus sign. That's fine. Some of you guys will see something that looks like a fraction, and then in parentheses, then multiply it by another fraction. Whatever, all the steps are the same regardless of what kind of grid you're working with. Let's see here. The next thing is write the given number in the unit in the upper left-hand corner. So you'll be given some kind of unit in the problem. This is my grid. That given is going to go right there. So the third, copy the unit from the upper left to the lower right corner. So right here, we'll be given some number, we'll say we're in grams. So the gram in the upper left corner is going to go to the lower right corner. So just the unit, no numbers yet. Okay, the fourth step, write the desired unit in the upper right hand corner. Let's say we're going from grams to kilograms. So do your given number of grams. Now you're going to go grams in the bottom right. We're going to kilograms, so we'll put that in the top right. That's our our desired unit. And 5, fill in the correct numerical relationship. So do the conversion factor. So if we're going, our same example, given in grams, we put our grams in the top left, have to have grams in the bottom right. We're trying to convert to kilograms. Well, your conversion unit is going to be 1,000 grams in 1 kilogram. That's where that chart from the last slide is going to really come in handy. You need to be able to do that, make those conversion factors. And we're going to keep going. Number 6, cancel any units which appear in both the numerator and the denominator. So this is, remember, this is top, this is the bottom. So if we go back to our grid again, we have grams here. We're given grams. Remember, what's in the top left goes in the bottom right. We're going to kilograms. Well, grams appear in the numerator and the denominator, so we mark those grams out. They cancel out. So we end up in kilograms. Number 7, multiply everything that is above the grid and divide by everything that's below the grid. So, if we stick here, if we were given 50 grams, and there are 1,000 grams in every 1 kilogram, we would do 50 times 1, put that parentheses. And then you divide that by what's on the bottom, 1,000. Top, multiply the top, divide it by the bottom. And then number 8, let me clear this up for you. Express your answer in the same number of sig figs that you were given the original problem. Of course, you can never forget about your sig figs. It shouldn't be a shocker. And 9, the units which did not cancel are the units of your answer. So it's going to be your desired units if you did this correctly. So let's do this with some practice. How many hours are there in 190.7 minutes? Well, first thing, you got to start your grid. You are given 190.7 minutes. So 190.7, we'll do MIN for minutes. Okay, those are first few steps. You have minutes in the top left, so you have to go ahead and put minutes in the bottom right. Okay, now we're going to hours. So our given to goes in the top right, so hours. Now you do your conversion factor. How many minutes are in every hour? There are 60 minutes in every 1 hour. So now you can do 190.7 times 1, put that parentheses, divided by whatever's in the bottom, 60. So that gives you some number. Now how many sig figs are we working with? We have 1, 2, 3, 4 sig figs. So our answer has to be in 4 sig figs. It's 3.178. And then our units are hours. Because our minutes in the top left canceled with our minutes in the bottom right, leaving us with our unit in hours. The next one you're given is 378.4 centimeters. So 378.4 centimeters. Then you're given the top left corner. You have centimeters in the top left. You've got to put centimeters in the bottom right. You're given your desired unit is meters. So there you go. Now how many centimeters are at every meter? Well, there are 100 centimeters for every 1 meter. So you do 378.4 times 1 again, and then divide that by 100. Now how many sig figs are we working with? 378.4. It's 4 sig figs. And then our units. Our centimeters in the top left canceled our centimeters in the bottom right, so we're left with meters. There we go. Last one, you're going to convert 4.32 times 10 to the negative 4. I'm going to assume that's meters, or grams, I'm sorry. Grams to milligrams. So there's your given the top left. You got grams in the top left, so you got to have grams in the bottom right. You're converting that to milligrams. So how many milligrams are in every gram? There are 1,000 milligrams every 1 gram. So you do 4.32 times 10 to the negative 4 times 1,000. That's going to make this a bigger number. So, or just make that down by 3. So it's 4.32 times 10 to the negative 1. Negative 1 grams. I know I'm going through that fast. I'm not writing real legibly. Just got a lot to go through with the time we have. Okay, if you don't understand that, you'll get plenty of practice. The 2-step dimensional analysis, you're just going to do 2 1-steps, but you're going to combine them together. So the first thing you're going to do is you're going to convert to the base unit. So if you're starting with kilograms, and you've got to go to milligrams, your base unit is grams. So first you can convert to grams, then you can convert to milligrams. Or you can go backwards. We're going from milligrams to kilograms. You just convert to your base unit first. So in our example, we're converting from 231 millimeters to kilometers. So it still works the same way. Your given goes in the top left, 231 millimeters. The top left. You have millimeters in the top left. You've got to have millimeters in the bottom right. And we know we're going from one side of our base unit to the other side of our base unit. So we're going to go from millimeters to meters first. And we're going to draw another grid. Now we have meters in the top left. We've got to have meters in the bottom right. And our desired unit is kilometers, kilometers. So now you just put in your conversion factors. There are 1,000 millimeters for every 1 meter. And there are 1,000 meters for every 1 kilometer. And then you can cancel units out. So if you want millimeters up here, cancel millimeters over here. Meters up here, cancel meters down there. You end up with kilometers as your unit. That's how this whole thing works. So to do the math, you would still multiply all the tops divided by the bottoms. It would be 231 times 1 times 1. Make sure that's all in parentheses. And then you're going to divide it by 1,000 times 1,000. 1,000 times 1,000. We're working with 3 sig figs, 1, 2, 3 sig figs. That should give you 0.000231 for each unit. So that's how you do those. If you want to